Example number 3, we are asked to graph the inverse parametrically. So we're asked to graph the inverse, but we're going to do it with parametric equations. And so they give us the function f of x is equal to x squared. And so the first thing I need to do is split this up into parametric equations. So think of f of x as y. And so to split that up into parametric equations, I could say y is equal to t squared if x is equal to t. Right? That would work, right? And so if that's the case, to graph that on my graphing calculator, this will just take me a second. Come in here. Alright, so if I bring my graphing calculator in here, bloop, bloop, bloop. I want to graph my function in parametric equations. So first let's graph the original function. So I'm going to say x is equal to t and y is equal to t squared. And so, and the parameter, I forgot to write this down, but the textbook said that we're going to consider in the original Cartesian equation that x would be greater than or equal to 0. Right? And we already kind of know what that looks like, right? Graphically, it's going to be the positive portion or the right hand side of a parabola, right? So anyways, the reason I'm talking about it is when I hit graph, I can't remember what I set my t at. And so if if I were to plug in some negative values for t, that would change the way the graph looks. So now that's supposed to go across the diagonal. So to put my diagonal in there, we're going to do another parametric equation, and so that's just whenever we want to plug in the diagonal, it's x equals t, y equals t. And so if I graph that, then I have my diagonal here. So now if I've done everything correctly, when I go to do my inverse, I should have a curve that reflects across this diagonal. In other words, this is my diagonal, and my inverse should be like this. And that's in function notation, but we're going to do it in parametric. So here's the cool thing about parametric equations. Remember that the inverse just kind of swaps the x and y. So if I just say x equals t squared and y equals t, right? I'm just swapping the y and the x's. That's pretty much it. It's real easy. That's why we went through all that headache of figuring out how to take a Cartesian equation and put it into a parametric equation. So, whoops. Oh, dang it. I didn't finish entering the thing. I hit the wrong button here. Y is equal to t. Alright, now we'll graph it. Boom. See how that worked? Perfect. So this is the inverse. Now, the cool thing about this is I could take this and then find the Cartesian equation. So I got to put those together. So really I'm saying that x is equal to t squared, right? But y is equal to t. So if I substitute my y in for t, then I have x is equal to y squared, or we could think of it like this. If I take the square root of both sides, I get y is equal to plus or minus the square root of x. Now based on the parameters and the way that we've set this up, we would be interested in the principal root, right? So we have two possible solutions, but the way that the parametric equation is graphed, we're only interested in the positive square root of x. And so let me demonstrate that for you real quick. So if I come in here and I change my mode to the parametric, or from parametric to function notation, And then I plug in x squared, and then I come down here and I say the square root of x. And then I'm going to set my window so we're only interested in the first quadrant. So I'm going to say 0 to 10 in the x direction, 0 to 10 in the y direction. And there it is. And then if I come in here and put the diagonal, obviously the calculators, they're a little skewed, but you'll see that it reflects across the diagonal. Boom. There it is. Any questions?